I just remember getting back and having this feeling of like, you know what? Whatever happens in my life, I can kind of hang my hat on that and say, that was a really tough, challenging thing I did, and I did it. And, it instilled a lot of self-confidence in me. I feel that way about graduate algorithms. I feel that way about anything. And I certainly feel that way about the OMSCS program as a whole. Hey there, welcome to Book Overflow, the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I'm Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toups. How are you doing, Nathan?
Doing great. Hey, everybody.
Well, thanks for listening, everyone. As always, like, comment, subscribe, share with your friends or coworkers, whatever you can to help the podcast. And again, thanks to the commenters. We've gotten some nice comments in the past couple weeks. One guy who was concerned about my sleep schedule. I think he had valid concerns. And so I did respond to him. So thank you for your concerns, everyone. And you know what? This episode is dedicated to him because he told me to take it easy a bit. And we're going to take it a little easy this episode. Not too easy. But one thing we wanted to do, just while it's fresh in our minds, more fresh in my minds than Nathan. If you've been listening to the podcast for the past 4 months or so, you have heard mentioned several times of a class called Graduate Algorithms. This is, that's what it's known as. It's actually Introduction to Graduate Algorithms. It's class CS 6515 at the Georgia Tech Online Masters of Computer Science, also known as the OMSCS program. It has been my final class of my master's degree. It has been brutal. I finished it, got my final grade back, and can successfully say I have passed the class. And just waiting for all the paperwork to be signed, but I will have my master's in computer science. And Nathan, you have also taken this class and have also gotten your master's in computer science from Georgia Tech. Isn't that correct?
Yeah, exactly a year ago. The graduate algorithms was also my final class. It was the big boss. And yeah, it's and I think the other kind of interesting thing, I think why we're excited to have this episode, we both got through the class our first time. That doesn't happen to everyone, right?
There's about a 30% retake rate.
Yeah. And so what we were really hoping is that we could maybe explore some of our personal experiences, not get into any of the details, the granular details. There's a very clear honor policy, but we can talk about our experiences. The class has actually changed from when I took it to when Carter took it. Though I think the core of it is pretty similar.
Yeah.
And I know that especially if you get on the subreddit for OMSCS, you can see this class and think it's the craziest, most insane class you'll ever see in your whole life. And I think for some folks that's true, but you can do it your first time. If you actually follow the rules and the guidance that has given with a lot of the wisdom that have come from other people. And I'm not saying that's a guarantee, but I think we can give you some strategies on how we got through it our first time. Because I will tell you, I'm a B student. I am a B student. I am not I was not valedictorian of my high school.
Neither was I.
Put it that way.
No, I think we both got solid B's in the class. And so, if you're listening right now, if you have come and found this special episode, maybe through the Georgia Tech subreddit or anything like that, please stick around. We hope we can give you our advice on graduate algorithms. If you're a regular listener and this isn't your usual fare, this is something we're doing just for ourselves. We wanted to, this is my kind of celebration week for graduating, getting my final grade back. And so this made the reading load a little easier. But we thought it was important to talk about really mainly for two reasons. One, because this topic does focus on algorithms, which are very fundamental to computer science and the different kinds of sort of basic algorithms. I found the class very useful and very fulfilling, despite being very challenging. Nathan, I assume you feel the same way.
Yeah, it ended up being on my top 3 favorite classes, even though it was pretty brutal.
And I think I would say the same.
Yeah.
But the other reason we want to talk about it is because I took it this year. Nathan took it. When did you take it, Nathan?
It was May 2024. So
about a year ago. And the class is actually, well, the material hasn't changed. The way they're conducting it has changed a fair amount, in part almost exclusively due to actually AI models, large language models, and how much better they've gotten. And it kind of really upended the class. And so Nathan took it when there was a strict no AI. Describe the AI usage policy, Nathan, when you took it.
Yeah. So there was a strict no AI usage. And I'll tell you, at the time, the models were actually pretty bad. Like
Yeah.
I would, just for giggles, I both applied cryptography and graduate algorithms. Like I would ask some of the questions to it just to kind of see what it would come up with, because the TAs warned us, hey, don't use these tools. Like, number one, it's not allowed. Don't use the tools. But also the answers are so laughably bad that you're going to get caught in 2 seconds, right? And so I was like, whoa, what are the answers? And I'll tell you, they're very convincing incorrect answers that were coming out. Now, the crazy part is that large language models have progressed so far. The thinking models weren't out a year ago, right?
Yeah.
And so, they also, most of them weren't agent based where they could go and talk to the internet and stuff. So it was all just, it was one of those things where I was like, it's like one of the smartest sounding liars that you've ever met. And it would give you a very convincing incorrect answer, especially if you didn't know the material. But people even with that, they would still do this stuff, and they would use it on like their homework, which in our case, homework was worth maybe 1% of your grade, like each homework was. And one person left the prompt at the top of their piece, and of course, and they're like, how would you like to fail out of the program because you cheated on something that's worth 1%, right? Like that was what they were fighting against. And it was crazy fight. And apparently the semester after, it got even worse. And then I guess, so what did they do to solve that problem?
So they wind up in my semester. So I think previously exams have been worth about like 60% of your grade, 67% of your grade or so. And then the rest was kind of homeworks and things like that. My semester, they just said, okay, we're still doing the homework. It's still graded, but it's not weighted. So you still got the feedback, but they said, so now it's just 3 exams and it's worth 90% of your grade. But what happened was, not only did it open up interclass collaboration on any assignments, but they said kind of, hey, go nuts with the AI models. Use them however you want. And by the time I take it, just a year later, now the thinking models have come out. I personally used ChatGPT's O3 mini high model. And it was fantastic. As a tutor, it understood the stuff very, very well. We're going to talk more about it as we get further in the episode. We want to give some background on kind of what the program is and all of that. But we just thought this would be an interesting way to sort of analyze, like, okay, like how is the software engineering industry changing in even just a year? And what real world effects are we already seeing? And this is a small one right now, just how Georgia Tech is running their graduate algorithms class, but it's a real one. And I think we can draw some inferences from this to how the industry as a whole is changing. So we're going to talk about all of that today. We'll start off with some background on the degree, kind of Nathan and I's, history with it, and more after a quick break. And we are back. Thanks for listening. So let's talk about the Georgia Tech OMSCS program. This is, I guess, we mentioned on the podcast before, but if you're not familiar with the lore, Nathan and I both met through, not even necessarily the program, but through the subreddit. I was looking for someone to do this podcast with me, and I thought, okay, well, who'd be a glutton for punishment? And I thought a Georgia Tech online master's student. And so I posted on Reddit. Nathan was kind enough to respond, and the Georgia Tech subreddit, and we were off to the races. And so why did I think, okay, why would a Georgia Tech master's student be an ideal partner for this podcast? So let's talk a bit about it. The way the Georgia Tech master's program works, it's completely online. Every program is in the massive online course format. And so all of your classes are going to have between 400 and 1,000 students. So it means there's very little guidance. You very rarely interact with a professor, almost always TAs. It's very, very self-driven. And it's designed for working professionals. It's 10 classes long. They consider full-time to be 2 classes a semester. So most people take 1 class a semester. And so you can get out in about 3 years and some change with that, since there's 3 semesters a year. Other people take longer. I've seen people take 5 or 6 years. I think it's rare to see someone get it done in like under 2 years, but some people do. How quickly did you get yours done? Because I did 6 semesters of 1 class and then 2 semesters of 2 classes. So I got out in just over 2 years.
Yeah, mine was similar. I started in fall of 2021, and I finished in spring of 2024.
Okay, so we're just a year apart, because I started in fall of 2022 and then finished in spring
and
of
I did the same thing. I started. They tell you like start with 1 class at a time, And it's funny because you'll see on the subreddit, all these people will jump in and take two of the hardest classes at the same time and then do really poorly and then go, oh no, I think I'm going to, fail out of the program. And I'm like, well, one of the major success criteria for this program is just follow the basic guidance.
Yeah.
Even if you're very confident that you can handle it with your workload, just ease into it. If you're straight out of undergrad, the expectations of graduate school are different. If you haven't been in school for a while, you're going to have to get back into the flow of studying and getting a cadence for this material, especially if you have a full-time job and especially if you have a family. In that case, we should give that side note too. Both Carter and I have had full-time jobs the entire time, and we both have families. Yeah.
Yep. Well, and so what makes the program so appealing for most people? There's there's a couple things. One, it's designed for working professionals. Everyone in the program I met had a full-time job. There's a fairly low barrier to entry. Like Georgia Tech, the reason they created this program is because they realized that they had kind of a basic threshold for their master's degree students for their on-campus program. And they realized that if most people who met that basic threshold succeeded in the program. And so they thought, how can we expand this education to the people who meet that basic threshold? So that led to the creation of the online program. It's a really great deal. It's about $6,000 for the entire degree, which if you're familiar with
it's cheaper than most summer boot camps that people do. Yeah.
It is a fairly low barrier to entry. Like I think the minimum requirements are like a cumulative 3.0 GPA and a couple CS classes under your belt, along with some letters of recommendation. They say preferably from academics. So that worked out well for me because I have a minor in computer science. But Nathan, how did you take any college classes or?
So it was really funny because sometimes people would come in with these really wild criteria inside of OMSCS. They're like, oh, I have an undergraduate in electrical engineering and I've done all this stuff. And would I be okay in this program? And I would always come in kind of snarky and just be like, I have a BA in theater. And I've had this really unconventional path. So I'm a self-taught programmer. I worked in cloud computing. I ran my own business for years. And so they still let me in, but I had a couple of open source projects that were on GitHub. I had some professional recommendations. So the head of engineering at a company I was working for, he's very much encouraged me to do this program. This guy who's the head of data science, and then another head of data science from another company I'd worked with. I had really good, and the guy from the other data science program was also an alum from OMSCS. He's actually one of the people that made me realize I could do the program. And so I had really great professional ones. So that's the thing. I didn't have academic references. I didn't have a conventional past. I still got into the program. And I think I'm one of those where I would not have been able to get onto the on-campus program. Like I didn't meet the traditional criteria. And one of the things I like about this is they've been very open about this. Dr. Joyner, who's like in charge of this program, they wanted to see if they loosened the criteria a bit, and with knowledge that there's going to be a larger failure rate or at least a larger dropout rate of this program, is there a profile of success story that maybe didn't meet their criteria for on campus, right? And if you look at that as the way of how they're allowing OMSCS to happen, I think this is really inspiring and cool. It's somebody
it's really cool.
Yeah. I mean, I was in my mid to late 30s when I even applied for the program, got in after lots of years of professional experience. And yeah, it was really cool. The other thing is, it might sound like, oh my gosh, everybody's going through this program. I did the math recently. Fewer than 20,000 graduates out of this program since they started it.
And it's been around for a long time, about over 10 years.
Yeah, exactly.
I had gotten accepted into a few kind of online master's programs, and I went with Georgia Tech because they've been doing it for so long. These guys are like, they've got this kind of down to a science.
Yep.
And
it's also, this is the on-campus. Here's the deal. Every class that you take in this program has an on-campus version of it. Now,
exactly.
There are on-campus classes that are not available online, but every class that you're taking online is the same professors that are running it, but they're a little more hands-off than on campus, and you're going to work a lot more with the TAs. I will say, though, There are some of the big main classes that are really large. I actually ended up taking a decent number of classes that had smaller attendance counts.
Oh,
and
nice.
and the professor was more hands-on. Like even applied cryptography, which has a decent number of folks, several hundred, the professor would still do weekly question and answer office hours, right? And she was very hands-on. I appreciate that. I love cryptography, so that was like, I didn't have to take that class. It was an elective. Most people are like, why would you do that? It's a very mathy class, but I loved it. And so that was a part of the experience that was really cool for me.
Yeah, so they're pretty generous with who they let in, but then they require that you get a B or better in 2 foundational classes.
Yeah.
I think within like your first year or something like that. So their thought is kind of, we'll let people in, and if they fail out, they fail out, right? And it's kind of nice. It works out well for kind of both parties, because Georgia Tech doesn't have to be super strict in admissions, and they get a little bit of your money if you fail out, but not so much of your money that you're like financially ruined. You know, it's like, it'd be like $1,000 if you took 2 classes and failed both of them. So yeah, super, super cool program. And like you said, Nathan, I mean, this really does make the possibility of a master's degree so much more available to the people who want it. Now, like Nathan said, they're not handing these things out like candy. This is a grueling program that's going to take you like 3 years to finish on average. But just for someone like me, you know, I had 3 kids when I started this. I have 4 now. I was working professionally. There was no reality where I dropped out of the workforce to pursue a master's degree.
Right.
But if it's something I can do in the evenings and on the weekends and kind of slow roll it over a couple of years, absolutely. So I think I feel very grateful to Georgia Tech. Nathan, I imagine you feel the same way.
Yeah, I've never been to a top tier school. I went to a good public university. I went to LSU for my undergrad. Nice. But Georgia Tech has a lot of, I've never had a degree where somebody goes, oh, Georgia Tech. Like that, it was a really interesting experience, because I'm just not, from that world. And I think Georgia Tech is, they're always in the top 10 computer science programs.
Yeah.
I think their master's program is hovering between 4 and 6 or so, depending on which list you look at. And the other kind of cool thing, and I don't think we talked about this, there's specializations.
Oh, yes.
So you pick a specialization, and that kind of chooses, I mean, a lot of us have crossover foundational classes that we have to take, but a specialization would be like in AI, or in my case, I did computing systems. I think you did the same?
Computing systems, yep.
Yep. I wanted computing systems because, again, my background was SRE and DevOps work. It had a lot of overlap with the, bytes over the wire and fundamentals of data structures and databases and networks and stuff like this. It's just very compatible. I know folks who work in AI, and my, comfort level with things like linear algebra and statistics are a bit lacking. And so I was just like, I'm going to put extra pain on my shoulders if I try to go down that path.
So yeah, I mean, it's a great program. We really can't say enough about Georgia Tech, or enough positive things about Georgia Tech. And it's a program I'm proud of. If a recruiter ever said, oh, it's the online masters, I mean, I wouldn't be ashamed of it, right? I would defend it and say, here are all the reasons that it's a great program, and why I'm very proud of my degree. And so, there are some places that are kind of just degree mills. We know that. This is not one of them. I think both of us are extremely proud of our degrees that we got from there.
For sure.
Proud Yellow Jackets here. And so, great program. And so I guess maybe we'll talk about, just a bit before we get into graduate algorithms, why we decided to pursue our master's degree, because both of us were employed at the time. We had software engineering jobs. So maybe you go first, Nathan. What made you want to get a graduate degree in computer science?
I wrote on here, for the lulz. So this was in the depths of COVID. Some people start baking bread. I went to graduate school. I think that was, we all have our stories of like the crazy thing that we did when the lockdowns were happening. In seriousness, though, my wife has a master's in accounting. She was CPA, and actually really enjoyed doing more of the analytics and business intelligence type work at the last company she was working for. She was working at a jewelry company called Kendra Scott when we lived in Austin.
Oh, Kendra Scott.
Yeah. And so they were doing aggressive growth, and she just kind of got thrown into business intelligence and analytics stuff. So when we actually moved down to Costa Rica, and while we were down there, she took some time off work. We had a young child. And she learned about the online masters in the online masters in analytics through Georgia Tech. It's like another program, a lot of crossover, and more expensive. I think it was like $10,000. Like not quite as, it's still affordable though. She went through the program, and so I got to watch her go through it and see kind of what the shape of the material was like, and how somebody could just kind of a spoonful at a time get through a program. And about a year after we had moved back to the United States, when we were in Colorado, she finished the program. So she took her less than 3 years, a little over 2 years, I think, is what the entire program was. And so I was kind of familiar with it. And also I was like, I never thought of myself as somebody who could do academic programs, but while she was doing this, I did the Stanford online cryptography class. It was the first taste of like an online academic program. Very good class. And if you do nothing else and you just want to learn more about cryptography, I think you can do it through Coursera. It's free. If you want to like have a monitored test that shows that you actually completed material, it's like $80 or something.
Nice.
But I got through the program and loved it. And I was like, wait a second, maybe I should think about a master's. And so I was encouraged by that engineering manager and other folks. It was probably end of 2020 when I got in my brain, and it was, early 2021 when I got accepted, and then it was fall when I got to take my first class. And yeah, I just was like, I know what I'm signing myself up for. The world was really weird. I think from a practical standpoint, I was in my, late 30s, and I was like, I haven't had any age discrimination issues at this point. But if I do want to move into like leadership, I think having a master's would be a good move. Like I know a lot of this material, but it would be really nice to get like a little stamp from a really nice academic institution, so that if me versus another person is being considered for a management role, well, I've also got, some of the ivory tower behind me. So that was kind of, I did it just to do it, but I also was like, when I'm 50, I might really thank myself that I've had a master's for, 10 years or whatever.
No, absolutely. Mine, COVID was the genesis of mine too.
Oh, cool.
I was in Orlando, working for one of the major entertainment companies there, and got laid off. Just, that's not a great place to be during COVID, working for a tourism company. And so I took a job with, wait for it, if you're a listener to the podcast, you know it, that awful little startup. And I was there for like 3 months before I'm like, screw this, I'm out of here. But I wound up getting another job that was much better. But part of the reason when I worked there, and the startup is unnamed, no one knows anyone who works there. I wouldn't want to flame anyone inappropriately. But I just remember kind of having a realization there. I was just like, oh, all of the bad engineers need to work somewhere too. And I just thought to myself, like, how do I make sure I never work here again? How do I make sure that I never work with the bad engineers again? And I just thought, well, you can't be a bad engineer. You have to be a great engineer if you want to work with great engineers. And so I thought, okay, so I got a lot of learning to do. And I thought, well, how do I signal that I'm a great engineer? And I'd heard about this program. I don't remember exactly where, but I thought a master's degree in computer science, that would be a great way to signal to recruiters that I know my stuff, that I'm, a good candidate, and hopefully propel me to, it wasn't like a direct like compensation thing. Like I'll get this to get more money. It was more like, by getting this, I think I can avoid working at places like this again. And as someone, I don't have a bachelor's degree in computer science. I never want to be filtered out through automatic resume, software for not having that bachelor's. And I just felt like I had some fundamental gaps. I was just like, you know what? I don't really know what the internet is. Like, I don't know how something gets from a data center in Virginia to my computer. I didn't know a ton about operating systems, even databases. And so that's why I chose a computing systems specialty, because that has kind of the most bread and butter courses. And so, I felt like it was really worth it for me. I really did fill those gaps. And in my most recent round of job searching a year ago, I hadn't finished the degree, but I had it on the resume. And I had some recruiters remark on it like, oh, we're glad to see you're pursuing your degree. We're not considering people without technical degrees at this moment.
Yep.
So, it worked out well for me. And so with that, one of the required classes in the computing systems specialty, which Nathan and I both took, is graduate algorithms. everyone kind of leaves it towards the end because you get seniority for picking your classes based on how many you've done, and just one of those like self-fulfilling prophecies where you can only take it at the end. They've actually made some changes so you can take it that make it easier to take it early now. I would recommend it to anyone listening to this. Try to take it early, not your first class, not your second, but maybe your third or fourth. Some people just get wrecked by this class, and if you are the person who gets wrecked by this class, there's no shame in that. And there are other specialties which do not require it, so it might be worth considering readjusting your schedule. The problem with taking it 10th and last is there's so many people where they have to take it. It's their last class. They want to graduate. They've already bought tickets to commencement. They fail it, and they've got to retake it. So it's rough. And there are some people who take it 3 or 4 times. I think that's very, very rare. But like Nathan said, it's not as rare to have to retake it once. Nathan and I did not retake it. We both got out the first time, both got solid Bs. I think I'm like in the exact middle. Like in this class, a 70 is a B and 85 is an A. I got like a 79. I think I got like an 80.05 or something. And so like it's about as no man's land as you can get. And you got a B2, right, Nathan?
Yeah, and I actually I recalculated my B, a very high B. I think I was like 3 points away from an A.
Oh, good for you.
Yeah, but I got almost exactly the same grade using the new rubric. So if I dropped all the homework and just weighted exams, so I mean, at least in my case, it was still fair, and it wouldn't have changed my outcome. Like at first, I was like, oh, maybe I'll have made an A in this class because I actually. I didn't perform as perfectly on all the, homework and coding assignments, which I guess there was no coding assignments this year, was there?
They were purely optional.
Okay. Yeah. And they really downplay this too, because it is funny. This is some people love it or hate it. It's a very math proof. And of course, anybody with a real mathematics degree rolls their eyes when I say this.
Yes, exactly.
But it's a math proof light sort of course where you need to think through a problem, describe the way that you're solving that problem, and there's a very specific criteria of truth statements that you have to make, and each section kind of has its own sort of way of doing this, and I think the format of that is probably the thing that people struggle with. I didn't meet a single person I had a group with 2 people that were retaking and 1 person that was taking it a 3rd time. They were all very smart people who struggled with the format or got tangled up in their own mind and made a fatal flaw on enough stuff that they had to retake the class.
So yeah, let's talk a bit about, because I want to talk about the format, but just give some context on kind of like, okay, so we're talking about graduate algorithms. So what are we talking about? And like, it's dumb, but like we're talking about algorithms, right? And we're talking about kind of some of the fundamental types of algorithms. These are one thing I like about this class is I actually, I said before, I speak LeetCode as a second language. I'm not naturally gifted at it, but I've practiced it enough that I do fairly well on it. But there are some kinds of LeetCode problems that like I just told myself like I can't even try. Like I'm not even going to attempt to learn this because like it would take so long to learn it, and even if I did, like the chances that someone would ask it are low. I'm just going to accept that if anyone asks a problem in this kind of bucket, that the interview is shot. And so like what buckets I'm talking about in particular, dynamic programming and divide and conquer stuff. That's I know are kind of notoriously difficult LeetCode problems. Dynamic programming is the idea that you can kind of build the solution to a problem from the ground up, and that you build one base solution, and then each solution after that kind of builds on the previous solutions. A classic dynamic programming problem is the steps problem, which is if you're trying to get to, there's a staircase and you're trying to get to like step 9 or whatever, and you can either take 1 or 2 steps. How many unique combinations of steps of ways to get there are there, right? And you're like, what the freak? How am I supposed to figure that out? And the answer is it's a dynamic programming problem, which is just basically that every step you're on, is the combination of 2 different unique ways to get there, and it's how many unique ways there were to get to the step previously before it or the step 2 steps before it. Because think once you're on that step, you can either take 1 step to get to the next one, or if you're on the step below it, you can take 2 steps to get to the next one. And so that's kind of the idea. And so the idea is you build all the combinations of steps for all the steps below you, and then you just add those remaining two. It's a very clever, elegant solution once you think about it.
Yeah. And to the uninitiated, because I think it's really easy, especially when you start getting into the bigger tech companies, leak code is sort of a courting ritual and a filter to get engineers who understand what are called big O, think time and space complexity of how to like solve problems efficiently, right?
Mhm.
So you might be given this problem, and then you're expected to solve it with O in or O login or some sort of threshold for how efficient the problem should be. And so typically there's a naive approach that's also, they call it like the brute force approach, that's not very efficient. And in this class, you will not get a good grade if you do it the brute force way, right? The brute force way is it does not demonstrate that you understand the characteristics of a specific algorithm, that in computer science, someone has solved this in an incredibly efficient way. If you can demonstrate that you know how to solve some variant of this problem in a very efficient way, then you get full credit and you express yourself in the way that they expect you to express it, right? And this is not that different than how leak code interviews happen at places like Google, where they give you some it's kind of like a little brain twister puzzle. You have to they want to see how you think through the problem, and they want to know how efficiently you can solve this problem. And there's a very clear criteria that you can demonstrate how to do this, especially in the dynamic program, and also what they call divide and conquer, which are all the things like binary search.
There's some
log.
Fast select. There's some classic algorithms there. But binary search is the biggest one, which is like sometimes the best way to solve a problem is to divide and conquer, right? You cut the problem in half, and then you can solve the problem on that half of the problem. Then you cut that in half, and then that in half, yada yada yada. And then there's a whole section on graphs. That's your classic graph theory. That's your Dijkstra's, your breadth first search, your depth first search. You have things like minimum spanning trees. You have finding a max or min flow within a graph. I guess max flow probably. And then, and so kind of like a problem there might be like we're trying to be really careful. Again, there's an honor program about not sharing anything from an exam or even a homework problem, like give a graded homework problem. And so obviously those are the ones that are most clear in my head. And so I'm trying to remember if there are any like notable practice problems. I can't think of a ton off the top of my head, but if you Google kind of like Dijkstra practice problem or Dijkstra graph practice problem or max flow practice problem, you'll get an understanding of what we're talking about. And then there's a final unit, which is NP complete, which, Nathan, do you want to give our listeners the 2-minute spiel on what NP complete means? Because I know this was one of your favorite units.
Yeah, I loved NP completeness. So there are a set of algorithms that are solvable in polynomial time, meaning I can build the algorithm, and for instance, the dynamic programming, divide and conquer, right? I can both solve it and prove that I've solved it correctly in polynomial time. Polynomial time means I can follow the set of steps and I can do it within an amount of time that is, understandable. Non-polynomial time is a set of problems, or NP. Non-polynomial time is where the domain of all possibilities of how solving a problem cannot be solved brute forced in polynomial time. That these get exponentially more complex, and I can't just prove that something is correct to a maximum or these other things. But
a classic would be the traveling salesman problem.
Great example. Traveling salesman problem is this one where you get all of these cities and you say, I want the most efficient path for the salesman to travel through all cities exactly once. Right? That sounds very simple, but as soon as you start adding a non-trivial amount of cities, this is exponentially complex, and you struggle with things like, can you actually say that this is the maximally efficient way of doing this? Now, one interesting way to get around it is that you can actually have a budget and say, I want the most effective path that fits within this criteria. You put a constraint on it, and it makes it so that it is solvable in polynomial time. But the thing about NP hard problems and NP complete problems is that while solving them from brute force is non-polynomial time, the proof that something is correct is in polynomial time. So I can
just to point out with the budget, it actually doesn't make it solvable in polynomial time.
Right,
It does make it verifiable.
Verifiable in
polynomial.
Yes,
polynomial
thank you.
time.
Yep. See, I would have gotten marked off on the test because I've been away from it for a year. But you're right; it's verifiable in polynomial time because again, you can't verify this is the most efficient out of all possibilities. But you say this is a solution that meets the budget, right?
Yeah, it's the trip is less than X miles. That's
right.
Pretty easy to verify.
Yep. And so so these NP hard problems, it's interesting. There's like polynomial time, there is NP hard, and then there's NP complete, which is like a subset of these. And there's a conjecture that that P does not equal NP. The conjecture means that we haven't proven this. Most computer scientists, like they estimate around 70-something%, think that P does not equal NP, meaning that there is no polynomial time way of solving NP problems.
Uh-huh.
But there's about 30% of computer scientists that think it might be possible that these things do. And if that's the case, there's a bunch of things that we rely on, like
cryptography, right?
Asymmetric cryptography, right? Like any public key cryptography.
And the idea being that it's very difficult to generate the key. Not that. That once you have a key, it is very easy to verify that it's the correct key if you have the solution. Right. But without the solution, it's incredibly hard to kind of to verify the key. Or I'm not good at cryptography.
Right. So there's the two big problems, right? So there's and again, this gets into cryptography, which is my favorite area. And I will say, while RSA and Diffie-Hellman are both within the NP, they're in the NP space, like non-polynomial time. They are not NP hard problems. And
they're not.
Sorry, NP complete. They're not NP complete problems. And we'll talk about this separately. There is no transformation of RSA into 3SAT or some of these other problems that we'll talk about. But if P equals NP, that means that there is a solution for it, even though it's not in this other section. What makes RSA and Diffie-Hellman difficult, or non-polynomial time to brute force? It's that Diffie-Hellman is what's called the discrete log problem, which is that figuring out the discrete log of this large private key is non-polynomial time to brute force that. RSA is factoring large primes. So you have to figure out P and Q, these two large primes. And if you just try to brute force it, non-polynomial time. Now, if I sign something and use my pub key and my signature, you can verify this very efficiently. And we do this all the time. This is where like public key cryptography and Diffie-Hellman stuff comes from. It's the magic of these, what are called one-way functions, where I use something that's secret. I do something, you can verify the output very quickly. Really cool stuff. Really, really cool stuff. And I will say, you might go, wait a minute, why are you taking a whole section on unsolvable problems? And I think one of the TAs brought this up in a really cool way, which is if you can identify that, let's say your manager comes to you and goes, hey, I need you to give me the most efficient way of reaching out to all of our customers in the easiest way possible. And I want it to be like the most efficient way. And you go, that's the traveling salesman problem. It can't be done, right?
Yeah.
I can give you I can give you a shortcut, and here's why, but if you don't recognize this, you might, without an education in this, you might go down the rabbit hole of trying to solve the traveling salesman problem, and you're going to be sad. Like, you'll be sad. You won't solve this problem because no one has. Oh, maybe you will, and you'll get, there's like $1 million prize, and you'd probably be the most famous person in the world for computer science for the next 100 years if you did it.
This unit's really interesting because you're not even creating your own algorithms at this point. In fact, what you're doing is they'll give you an algorithm, right? Like a new kind of problem. And they'll say, prove that this is NP complete, right? And so you are basically proving like this is at least as difficult as another NP problem, or a problem known to be NP hard. And all the problems that we had were NP complete.
Oh, and
And
sorry,
so
I'm already gonna get corrected. It's not non-polynomial time.
it's non-deterministic.
It's
polynomial
non-deterministic.
time.
It's non-deterministic polynomial time. I know. Roast me in the comments. I always shortcut it. It's not true. It's non-deterministic.
Someone took this class a year ago. Well,
Yeah.
someone just wrapped it up.
I know. Look at me. I know.
Anyhow, so what you do is you do these reductions. And so if you've taken like a math proof class, you understand a reduction. But basically the idea is you demonstrate that any instance of the given problem, the new problem you're trying to prove is NP complete, could be transformed into an instance of a known problem. Because basically what you're saying is like, listen, if in polynomial time I could transform this problem into one of these problems that's known to be NP complete, then I can prove that if I had for that's how the reduction works. It's oh gosh, it's any instance of problem known to be NP complete. Yes, it's any instance of problem known to be NP complete could be transformed into an instance of the new problem. Because basically what you're proving then is you're saying, if I found a way to solve the new problem in polynomial time, then I would also have a way to solve the existing problem, the known problem in polynomial time. And then that would prove that P equals NP. So you're basically proving these two things are equivalent. And that's kind of how all NP complete problems work, is they all reduce from each other. And any problem can be reduced to another problem.
And that was the kind of fun thing. It's like you're proving that this is at least as hard as another known NP hard problem.
Yeah.
And so, you have this known one and you say, okay, and it was funny, you'll get this magical black box. You'll say, hey, you've got this new weird algorithm and it knows how to solve if you put something into the black box, this answer will come out.
Yeah.
And if that was true, if there's some algorithm somewhere that did this thing, show that this would also solve this other known problems. And so you'd have to be able to transform, like manufacture some sort of input, go through the black box, have the output, and then transform it back into something that would actually prove this other known NP hard problem. And if you could do this, then you knew that you've broken the NP complete domain set. And what's neat about it is that there's all these problems like the clique problem, 3-sat, there's a bunch of versions of independent set that they all we already have known proofs that show that if you have something in this format, you can translate it into another format. And this happened back in the 70s. There was I think it was it Knuth? It wasn't Knuth. Who was it? Oh, this is going to drive me nuts. It was very famous computer scientist that I'm like drawing a blank on, that basically came out, I think, with like 7 equivalents. And because of these, all of like thinking about translating between all of these types of problems, like actually traveling salesman is one form. Sudoku is also one.
Oh, interesting.
Yeah. So and we didn't go over Sudoku in this class, but there is an infinite plane Sudoku is also an NP complete problem. And,
Super Mario is NP complete. There's a great YouTube video where someone demonstrated that Mario is an NP complete problem.
Oh, and so maybe this would be a good way to think about it. Sudoku is an interesting one. Solving a Sudoku takes a while, right? You have to go through and figure out all the numbers that go into this, but it's very easy to verify. Actually, I did this for a job interview once. I had to write a Sudoku verifier in a 1-hour window and pulled it off. So that was like a fun thing.
That's a clever problem.
It was a fun problem because you basically have to have the solver has to go 1 through 9 is unique for every row, 1 through 9 is unique for every column, and 1 through 9 is unique for every block of 3 by 3 block in a tiling. And so again, that algorithm is very efficient and very simple. If you do this on an infinite plane or a very large plane, 256 by 256 or something, you can see why solving for this becomes really difficult, but verifying it be very simple, right? And this is where that non-deterministic polynomial time versus polynomial time for verification.
So that's our overview of the material in the class. And We are not your professional tutors. I'm sure we got some things wrong in there. But what throws people for a loop with this class is the format of it, because we talk about all these kind of different algorithm challenges, but you're not coding in this class. The coding homework is optional at this point, basically. And really, they only give you the coding homework because they don't have time to grade a full free response problem before that unit ends. And so they just give you something that GradeScope can handle, the automatic grader. And so what are you doing? You're doing written free response questions. They're pretty strict on the format of like how they'll say like, okay, you need to give these sections, like for example, like in the divide and conquer stuff, they would say like, okay, the first is your explanation of your algorithm. The next is your justification of correctness, so why does it work? And then your last is the runtime analysis. What is the big O runtime of this, right? The NP complete section has a different format. Your graph problems have a different kind of format. This really throws a lot of students for a loop, is the free response section. Nathan, why don't you talk about your experience with these kind of written free response formats?
So I was very fortunate. I did really well for me. I mean, like I made in the upper 80s, I think, on the first exam, which is typically the first exam is like the shock for most folks.
It was for me.
Yeah, they underperform, and then you're trying to like crawl your way back and do a good grade for the rest of the semester. I came in and did really well for me again. Did really well on the first exam. Actually, let me pull this up because I still have my spreadsheet. Let me see. Google Sheets. I'm gonna.
While he's pulling it up, I'll say my experience with the first exam was not great. I did not have my study routine nailed down. I actually reorganized my life around this class. I was trying to study at night, which I'd done for the whole degree, but this class is brutal trying to study at night after a full work day and putting the kids down. So I reorganized my life to do this class in the morning. I went to bed at 9, would get up at 5:30, get about 3 hours of studying in before class. And that's what I'd say you got to put in for this class, about 15 to 20 hours a week. Of good quality studying.
I made an 81.6 on the first exam. So that
I got a 62 and 70 is passing. So I was in that you got to crawl your way out of.
And 80 is an A in this class, right?
85.
Is it? Was that still
85
the case?
is an A.
You're right. 85 was an A. So it was just shy of an A. I didn't quite make an A on this test. So I made just shy of it, but I was like, cool, I'm going to be okay. And so I get into exam 2, which honestly, I love graph theory stuff. I felt very confident in this. I did really well in the homeworks actually. And we get like an hour and a half or so. I can't remember.
2.5 hours at least at this point.
Was it 2.5 hours? It might have been I think maybe it was 2 hours. It may have been 2.5 hours. I can't even, it was a long time. I blast through exam 2 in like 45 minutes.
Nice.
I'm super confident. We only had 2 written problems and then a multiple choice section. First written problem, I'm like, nailed it. Second problem, I'm like, nailed it. Third, the multiple choice, I like knew it. I submit the exam. And then about 5 minutes after I go, I think there's an edge case I didn't think about in the first problem. And then the doom set in and I was like, I did not solve the generalized version of this problem. I'm going to get destroyed. Like it just like, it struck me and I ended up making like a 66.6 on exam 2.
Yeah.
And I was like, okay.
And so what was it about the free response format that kind of threw like?
So there's typically a naive case, right? And again, I think all 3 of these fit into this. There's always a naive case where you go through and you think of kind of like a simple version of the graph. And I go, okay, cool. Well, like for the graph I've drawn a picture of, the algorithm I'm describing solves this. And I'm fine. And then you go, hey, but what if there's multiple sinks? Or what if there's multiple sources, right? And in a graph, a sink is where the graph ends. If it's like let's say it's a directed graph. A sink is where it ends. And then a source is where things start. Well, did I handle those? Or is something routable across all things if I have multiple sources? Well, no, because you actually can't get back to a source. It's a one-way directed graph. Yeah, there's all these weird things to think about. And of course, I'm not getting into what the problem was, but maybe in my case, I needed a directed acyclic graph. That was like one of the forms of something. And it's interesting. they actually give us ways to transform, let's say, a graph of relationships into a directed graph, doing a transformation. And then with a directed acyclic graph, I could describe maybe some meta characteristic of the graph of like, how things flow. And so you have to kind of get your head around these. And so I actually did the correct transformations, but I didn't properly describe how I actually could prove that some graph was always a certain way or whether it was acceptable or not acceptable. And if I just spent 15 more minutes poking holes in my own ideas, I would have been like, oh yeah, generalize to here, describe it this way. This now handles all cases of the things. And that's what they're trying to get you to do, right? They want you to think not just how you're solving the immediate problem, but think through ways that this could go sideways, solve for that more general case, and then describe the time complexity of doing that thing. Because again, you still had to have, oh, well, I can do this with this clever trick you gave me. I can do this in O(m) plus n, which is good enough for this thing I have, or it's log m, and that's the prevailing piece, and you can disregard, and so you have to describe these characteristics of it, and that's the sort of ritual that's going on here.
Well, it's all written, it's paragraphs, right?
Yes.
They're very big. You don't write pseudocode.
Yep.
And have complete sentences, right? And that's where I would see a lot of students struggle because I will toot my own horn here and say that I'm a very strong communicator. I think there's a reason we have a podcast here, and hopefully you find that I can communicate my thoughts fairly well. And I'm a very strong writer. And I would say in particular, I'm a very strong writer compared to your average computer science student. And so actually on your advice, Nathan, because of that horror story you told me about your graph theory exam, I never took less than the fully allotted 2.5 hours. Even if I finished early, I would just sit there. I would like twiddle my thumbs and I would go over it and review all of my problems and things like that. But yeah, I would, because I'm like, I'm not going to, if there's any realization that's going to come, I'm just going to wait here until it happens.
So to compensate for exam 2, I ended up making an 88.3 on my final. So, or it wasn't a final. Actually, when I took the class, there was a fourth exam that you could take, and you would drop your lowest grade.
But that still exists today, but now it's just 5% extra credit.
Okay, which is I think that's really neat. I might have actually have taken. I skipped the final because 88 got me to a solid B in the class, and it was good enough, right? Like I got what I needed, and but an 88 though is an actual A, on the test, and I loved P and NP problems. Like it was so much fun. There's such weird puzzles. At this point, you've and what's actually built up over time, even though the NP complete work is very abstract, the way you communicated, like, oh, I have to transform this data before I put it into this unknown algorithm. This is this much time complexity, right? This is an ON transformation because you had to prove if you did something that was in non-deterministic polynomial time, well, I'm sorry, you can't do that transformation. Like you're verboten, right? Like you're gonna lose. And so you still had to like think clearly, even though you're like, oh, and then you're gonna go to this magical realm that solves this thing, and then I can take this magical solution and turn it back into a known algorithm, and now I've beat everything. So
so my exam history, first exam I get 62, and I just got wrecked. I did not have my study routine down. I even had a family trip to Disneyland within there, and so that just ate up a week. Was not taking this class seriously as it should. Really reformed my study routine for exam 2, which is the graph theory exam. And that, one of the things I'm proudest of, I got a 95 on that exam.
That's so cool. That's what I should have gotten. That's what I should have gotten.
I got perfect scores on both the free response questions and only just missed, I think, 2 multiple choice questions. And then my final exam, I got the grade back. I got an 80. So I got a C, an A, and a B, and then that all averages out to a B in the class. And so, it's that's kind of like the gist of the class. We could talk a lot more about kind of like study routines, and maybe we'll talk a bit about this, but I would like to talk about AI and how
Yeah,
AI
what a
has.
different experience you and I had with this. So
Exactly, because that's one thing. You gave me a lot of advice before starting the class, and a lot of it worked out really well. But one thing where your experience was very different from mine was AI. You said, don't use the large language models because
yeah,
they just don't know what they're talking about. But like it's a pretty self-directed class. I'm someone who, and that was also a different approach you and I had throughout the program. Is you really leaned into study groups and other students for a lot of the program, and like the Slack. I guess there was a big Slack group I didn't know about until the very last class
apparently it's
that
a
you just.
graveyard now. So
Yeah.
it's the
um,
not the case anymore.
but anyhow, but I like to operate a little more independently with my studying, and so I didn't really want, like, I'm not the kind of guy who, like, I like to watch office hours sped up afterwards, but not necessarily attend. And so, but sometimes you just need that the tutoring, the actual interaction, and so I thought I'd give the large language models a spin, and at least the O3 Mini High model, excellent. And and I would prove it, right? Because like they would give us a practice problem and a practice solution. I would feed the practice problem into the model, and I'd give it the kind of rubric, not the rubric, but the format for how the solution needed to be. And I'd say, answer in this format. And then it would answer. And then I'd compare it to the practice solution. And about 90 to 95% of the time, it was correct, spot on. And so I would go, okay, it knows what it's talking about here. And then from that point on, I could interrogate it like ruthlessly about the problem until I understood everything about it. And that's the other thing about this class is, like, as dumb as it is to say, like the best advice for it is just understand the material. One thing, and understand it in particular, the practice problems. And this is not hidden knowledge, not forbidden knowledge, but you do have to read between the lines for it. But the TAs will tell you if you kind of poke around enough. Because you might be thinking, my goodness, I get to this exam, how am I supposed to come up with this novel solution to a novel algorithm, in 2.5 hours? Like, that's crazy. The trick with this class is every single exam question was a twist on a provided homework or practice problem. And you just had to stare at it for a bit, and then you recognize, okay, that's this problem, but we have to do this differently. So it's very fair in that way, and that they're not just throwing completely new solutions. Be like, well, how come you haven't perfected that algorithmic thinking, huh? And so
Right.
I found the AI really useful because I could just really, really understand every single practice problem. And yeah, it honestly, it was a world-class tutor. I would not have gotten through this
That's
class
neat.
without it.
I think that's really cool, and I'm glad that they've kind of adopted with the times, because we are in a world in which these large language models aren't going away, and so adjusting the course, and so you're not an honor code violator cheater if you
Yeah.
use something that's useful to you, and instead they've changed the format of the class where you're taking a proctored exam. You either really know it or you don't.
And like, it makes them high stress. 3 exams, 90% of your grade. Like,
Right.
that is
Right.
tough.
And that's much more like traditional academia, right? I remember taking more traditional classes in college in the early 2000s, because that's how old I am, where the class was literally a midterm and a final. There was nothing else, right? It was a bunch of material. You had to, and then it was a midterm and a final, and that defined whether you passed or failed the class. One of the things that I found helpful, and I think it still translates even to now, even with this format changes, is, I mean, so all of the advice that the TAs give you, you should follow. And this is more true in this class than anywhere else. You're going to feel like you're drinking from a fire hose. It's going to feel overwhelming. You have to get comfortable with both of those things. You just have to know that there's no way to know everything, and that they're going to spoon feed you the stuff, these hints. Take it seriously. Like, go through the practice problems. And I will tell you, like, there are some folks in these classes, the ones who made solid A's, the ones who probably become TAs one day, who are amazing human beings. Like, you just watch how their brains work, and they would solve all of the bonus. There's like problems that were above and beyond what was expected in the class, and they would go and solve these problems and talk about them as a group. I never did that. I did the assigned problems that were given to us, plus I would go over the book problems after the office hours. Kind of started reviewing them, but I would focus on the primarily assigned pieces. And the other thing I would do, and this was just literally for me, so I didn't get tripped up in the format, they would give us like a model solution. And I didn't even worry, like, I looked at it and it was typically a pretty simple problem, but I would take the model solutions question, and then I would just work out solving the model solution and go back and look and say, did I format this identically? Like, did I, from my memory, did I say like, here's truth statement 1, truth statement 2, here's the verification, here's the, analysis of the time complexity. And I would just work on that until it was like absolutely what was there. And that seems really boring, but I'll tell you, when the nerves come in on the exam and you're trying to think about some creative new way of doing a problem, the last thing you want to do is be like, oh yeah, what was the format again? Like, how do I do the format? The format should be so boring and rote that you get to be creative inside of that framework. That was the biggest thing for me, was that like, you could kind of lean on that during the uncertainty that was inside the exam, of just being like, okay, I'm going to use the formula. I'm going to add my little creativity in the middle here, and then review and make sure I'm confident before I turned it in.
Yeah, when you see a lot of students who would see like, but I meant that, or I implied that, like, and their thing is like, well, you really didn't, right? Like,
Right.
I'd see a lot of students, and sometimes we'll see students complain and be like, I got the whole thing right, except I messed up one word, and then they knocked me off, 30% on the problem. And it's like, yeah, your one word is you said less than instead of greater than, right? Like, that's a completely different thing. That's like saying like, I made the code completely right, but because I missed one semicolon, the thing doesn't compile. And it's kind of like, well, that's part of the code compiling.
Or like, I made a slam dunk, but it was on the wrong end of the basketball court. You're like, it doesn't really matter.
Yeah.
I would say the other piece too is that like, have some empathy, which is, am I writing this in a way that it's as easy as possible for the TA to give me the best grade possible, right? That sounds ridiculous, but like literally put yourself in their shoes and you're like, am I writing this sentence in the easiest way possible for the TA to say, yes, they understand the material? That means that maybe you'll take a complex sentence and break it up into 2 simple ones, right? So you don't get tangled up in this if-then statement. Like on the non-deterministic, on the NP hard, NP complete stuff, there were 4 ways that you could prove the equivalence between A and B. And you could do one that was like positive statement to positive statement, not positive to positive. Like there's these like various things, and they were very important directionally.
Mm-hmm.
If this was true, then that is not true. And then there was this really crazy double negative one. It's like, for all A's are not true, then all B's are not true, which is the most difficult version to prove correctly. And they literally go, pick one of these and use it every time for everything, because you're going to get tangled up. And the easiest one was to do positive statement to positive statement.
Yeah.
And then like, and also like if and only if, right? IFF. It was like another one. You'd have to really wrap your head around what those things were. And if you screwed it up, game over. Like, you just don't screw those parts up. Like, get really, really comfortable with being like,
it's not like they'll take 1 point off. Like they'll take the problems are worth 20 points. They'll take 8 points off.
I deal with this with my 4th grader though. My 4th grade daughter will do some math stuff, and she knows the material, but she'll be sloppy in how she, does long division. And I go, look, the teacher doesn't understand if you're being sloppy or if you don't understand the material, if you give the wrong answer. It's the equivalent outcome, right? That you either don't know what you're doing or you're being sloppy. And like, don't be misinterpreted as not knowing what you're doing just because you're sloppy. Like, sloppy is the worst way to be wrong on these kind of tests.
Well, and and this is just something where I just have a gift for it. Like, some students really struggle with it. Like, they couldn't read through their own solution. Like, and it's so clear to them in their head, but they can't think. I think what you said, Nathan, about empathy is exactly the right way. Like, I would just read it. I would read through my solutions and say, could a third party understand this easily? And I'm pretty good about like following along with like, free response and noticing like the logical inconsistencies. Or like, oh, there's a jump here that doesn't add up. So let me add a sentence just to make that assumption explicit. But it's something I have a talent for. I can't even say why. But like, as something I don't have a talent for, like music. I have no talent for music whatsoever. Like, I'll listen to like jazz, and like the idea of someone doing like a jazz solo, completely incomprehensible to me. How you could solo something. And you might be listening and saying, oh, Carter, you seem like a bright guy. I'm sure that if you had just had that practice, you would come around too. No, I took piano lessons for 6 years. I stunk at it. I never got any better. My recital song was Phantom of the Opera. I played it for 4 months in a row. Never got any better at it. Never even memorized a measure of it. I don't know why. the only one of my brothers who is like this. All of the other ones are very gifted musicians. They all play the piano. They find it relaxing. I don't find it relaxing at all. The piano is about as relaxing as a math problem to me. I don't know why. My brain just does not work like that. And so this isn't, and I know that that's how it is for other people. Like, I can't explain why the written free response stuff comes pretty easily to me. Or at least not, like, coming up with the algorithm was hard. But once I had the algorithm, I had no doubt in my ability to execute on it. And I will say that out of all my free response problems, I never once got marked down. And this is true for the homework. This is true for all the exams. I never once got marked down for a formatting thing. Like, oh, I meant to communicate that,
Right.
but I didn't. All of my markdowns were because I fundamentally misunderstood a part of the algorithm.
And I will say,
it's just different for everyone.
For the professional career, this is a transferable skill. Even though you're not going to be asked to do these like TA, given formatting things, how you communicate to your manager and using empathy and understanding, like, my manager is trying to solve a problem. Can I frame the work that I'm doing in a way that both shows that I know what I'm talking about and helps the manager solve their problem when they go talk to their leadership? Or I'm working with an intern and I need to clearly communicate the expectations of a set of tasks that need to take place. Like, this empathy-based communication skill fundamentally matters. It doesn't matter how correct you are in your mind. If you can't communicate it, it doesn't matter.
Yeah, well, and especially written communication. Nathan and I are both at full remote places. It's very, very important. And I have a coworker he's excellent at this sort of stuff. And he'll apologize because he'll post these Slack messages, which he describes as rambling. These are not rambles at all. These are very well thought out and well structured opinions on the systems, or visions of what he has to come. Like, it is a dream and a pleasure working with him on this sort of stuff, because I never misunderstand what he's saying. And he's just very, very good at this type of written communication. And so that's a fun side effect of this class, is like, you will have to get good at communicating your ideas in a clear, effective manner. And so not only is that kind of fundamental algorithmic thinking transferring over, but that written communication is super important in a career. So yeah, some people complain about it and they say, well, I thought I was signed up for computer science class. Like, you did. This is computer science. It's just not coding, because coding, not all computer science is coding, right? And maybe not all coding is computer science.
I don't know. In my mind, this class really shows the difference between, it's like when you go from arithmetic into learning geometry or calculus. Like, arithmetic is sort of table stakes. You have to be able to do these basic conversions from one thing to the other. That's actually not the interesting part about math, right? The interesting part is like describing some complex system or doing these other things. To me, that's what coding is too. Like, coding is a way to clearly communicate to a computer what you want to have happen, these truth statements and things. The much more interesting thing is sort of gets into the John Osterhout ideas of philosophy of software design, right? Can I build this in a way that's maintainable, manageable, easy to reason about, efficient, and that's a higher order thinking. And I think that the coding part, again, it's like that being like, oh, I'm really good at coding is like saying, like, I'm really good at writing sentences. You're like, okay, can you write paragraphs? Can you write a 3-paragraph essay that has a conclusion, right? Can you write a novel, right? Like, of course you can write sentences. That's what you need to do. You need to be able to write sentences to create a novel. Writing a novel is not easy. And it takes a lot more higher order thinking of understanding character development and story and plot. That's what graduate algorithms is, right? It's this understand of like understanding plot points, or understanding these conventions of how I construct these larger and more important pieces, I guess.
Absolutely. And so I guess we can ask ourselves at the end, is it worth it? Was this class worth it? And the degree as a whole, was it worth it? We've talked a bit about this, but let's put a bow on it. Nathan, what are your kind of final thoughts about graduate algorithms and OMSCS?
I loved it. I got so much better at time management. All of us, you realize how many moments in your life you can optimize if you're not just like doom scrolling Twitter or wasting away on reels or something. There's so much time for self-improvement. There's so much time to push yourself and grow. I'm really glad I did that for a little while in OMSCS. I'm really glad I'm finished and I'm able to
Yeah.
do other things now.
Yeah, I really enjoyed it. All the positives we've talked about, they really improved my algorithmic thinking. I don't find this stuff like divide and conquer dynamic programming nearly as scary as I used to. Big, yes, the time management, absolutely. And you know what? I'll put a plug out here right there. There's value in doing hard things, and I was proud of myself for taking this class. I'd kind of had like a weasel strategy around it. Like if I fail this class, I could switch my specialization to one that doesn't take it. And I could take these two classes, which would be easier. But I'm really proud that I got it done. I remember feeling that way. I'm a Latter-day Saint, a Mormon, and I served a religious mission when I was 18, right out of high school. Right, you know what we look like: the white shirts and ties, the black name tags. I was in Brazil, and that was a really, really great experience for a lot of reasons. 2 years, speaking a foreign language away from home. I remember getting to day 6 of my mission and thinking, well, that's the longest I've ever been away from home. Like only 103 weeks to go. Um,
Oh, wow.
and I just remember getting back and having this feeling of like, you know what? Whatever happens in my life, I can kind of hang my hat on that and say that was a really tough, challenging thing I did, and I did it. And it instilled a lot of self-confidence in me. I feel that way about graduate algorithms. I feel that way about anything, and I certainly feel that way about the OMSCS program as a whole. When you push yourself to your limits and really, you stretch yourself. There's a lot of confidence building that comes from that, and there's a lot of if you struggle with self-confidence, it's kind of nice having those tangible achievements where you can point to and say that wasn't fake, that degree was tough and I did it. And I remember, and almost every single one of my classes, in particular graduate algorithms, I remember the moments of despair where I was like, this is it, I'm done, I'm finished, I'm not going to work my way out of this one. And I worked my way out of it every single time. And the next time you have a moment like that, it's great to have a library of moments like that in the past. And you could say, hey, remember graduate algorithms, remember Tabuão in Brazil, remember whatever, you worked your way out of that, you'll work your way out of this. So, and just a big, big thank you to the Georgia Tech OMSCS program. We are two proud alumni of the program. It is an excellent program. A big recommend to anyone in the podcast who's considering postgraduate education. And I think I can say I would not be the software engineer I am today without having done this program. Would you agree, Nathan?
Yeah, same boat. I think that a lot of our work we kind of try to stay in like sane defaults or best practices. And one of the nice things about getting a master's is it gives you a little more confidence when you know that the sane default's actually not correct, right? So most of the time you should like not build it yourself, not do these things. But every once in a while you might get into a problem now where I now go, you know what? We have a unique set of circumstances here, or we're solving a problem that hasn't been solved this way before. I think we actually are justified in venturing out, and here's why. And being able to have the vocabulary of talking about these things, or have the vocabulary to talk to somebody who talks me off the ledge and says, no, you're looking at this wrong, go use this safe path. I have much more confidence to have those types of conversations now instead of just kind of being like, oh, okay, I'll read a tutorial and I'll use Kafka because everybody uses Kafka, right? Or whatever.
Nope, I think 100% agree. And I think that about wraps us up. Thank you, everyone, for listening. We're hoping, we understand that this might not find our usual audience. We're hoping that this can kind of serve. There's so many questions in the Georgia Tech OMSCS subreddit about graduate algorithms, people nervous about it. Hopefully people can come back and listen to this podcast or watch this video and just, from the perspective of two alumni, figure it out, get an idea of what the class might look like, because it can be really scary going in, not knowing exactly what it looked like. If it changes as much in the next year as it did in the past year, maybe this video won't be helpful in the slightest. But to our regular listeners, hopefully you found this a fun personal episode. If not, that's okay. We wanted to do it anyhow. And we'll be back next week with Grokking Concurrency is our next book that we'll be reading. Yep. We've got 2 weeks on it. It's very technically, it's not heavy book. I don't know. How would you describe it, Nathan? It's very involved technically.
Very involved. And, we're going to get into some, we've gotten some feedback that folks would like us to get into some more deeply technical topics. And we're like, well, let's go. Let's do some concurrency.
Yeah. And I have now graduated. I'm done with graduate algorithms. So I'm excited to, there's only so much brain power you can put into researching deeply technical topics, and too much of that was consumed by graduate algorithms. So I'm excited to give my full attention to grokking concurrency. And as always, we thank you for listening. This podcast is a lot of fun to make, and we appreciate when you say that it's fun to listen to. So thanks for listening. You can always catch us at contact@bookoverflow.io, on Twitter @bookoverflowpod. I'm on Twitter @Carter Morgan. Nathan does his work with his newsletter, Functionally Imperative, at functionallyimperative.com. And yeah, you can find our book, our reading schedule at bookoverflow.io. Thanks so much for tuning in, everyone. We'll be back next week with our usual episodes. Again, excited to tackle grokking concurrency. And until then, we'll see you around.
See ya.